All right. The Ford team here with me today is part of a larger organization called Digital Product Design. Digital Product Design is an organization within Ford Motor Company that focuses on designing all the digital experiences inside the vehicles. Here's a quick sizzle that I'm going to put up in just a second to get you grounded on what our organization does that is in the wild today.
Can we get the volume turned up a bit in that?
All right, that's us. So my team is the 3D team. So our primary responsibilities are for creating and integrating the 3D graphics for Ford and Lincoln. We essentially create the awesome 3D visualization on top of a solid-driven HMI. So the Unreal-driven My Mustang HMI you'll see today will be in the new Mustang. The work includes, but not limited to, data prep, managing release data and prepping according to production needs. We also do offline renders, which are traditional pre-rendered image sequences, animation, welcome animation, drive mode, cinematic, et cetera. We also do prototyping, concepting new features, working with feature owners on new experiences that are not thought up yet with real time. These prototypes lead directly into production. Real-time experiences is our core focus now going into the future. We're prepping and implementing 3D content to meet design intent, working with UMG blueprints to drive functionality in the experience. We also do profiling and optimization, which is key to working with our software engineering. We put a high level of care into both aesthetically pleasing visuals and a seamless, memorable experience unlike any other automotive digital HMI. Unreal Engine serves as an integral tool that helps enable that level of care to become a reality.
Cool. So for those of you who might be new to HMI, especially at like UE Fest, there's lots of different industries around here. I'm going to kind of go over what the anatomy of an HMI system is and how Unreal Engine fits into this system. When I talk about HMI software, I generally divide it into 3 domains. You have the UI domain, which is where Unreal Engine lives. This is when you get in your car and you look at the screens. That's basically what you see. Next, you have the services layer. So there are applications running on the HMI system that are running in the background that are providing the UI with essential data. So a good example of this would be a routing service. So when you go and ask for directions to get from point A to point B, there's a routing service in the service layer that's calculating, figuring out which way you should go, and then it's serving that data to the UI. Another great example of a service that runs in the background is a voice assistant. When you go and tell your car you want to go somewhere or you want to turn up the temperature, there's a service in the background that's crunching what you said and turning it into an actionable item, also running as a service. And then finally, you have the platform. The platform contains the operating systems, the display drivers, CAN bus libraries, message bus libraries that the services rely on in order to get the data that they need and communicate that to the UI. So I have a simple example of these domains working together. Let's say in your UI you have a label that takes a string of a location name. You're driving through multiple cities, and every time you get to a new city, that location changes. And so we have a location name changed event that gets triggered every time the UI needs to update the label. That event is triggered by a navigation service, which is periodically evaluating where you are and then calling set location name to pass that string to the UI. And then that service, that navigation service, relies on GPS firmware maybe to do to pass in a location into a connected query maybe, or maybe you have a database where you can look up your navigation data and get your location. So why Unreal Engine? OEMs ask us this question all the time. And I like to set the tone with this diagram here. HMI development has a lot of overlap with game development. There are quite a bit of things in games that are important as well in HMIs. I have a list of them over there, but just a few, like high visual fidelity in real time. It's very important that the data you get in your car when you're driving is given to you in real time and is smooth and easily readable. I'm sure you've all had that sluggish experience in your car when you're trying to get information, and it's slow performance can be frustrating and also unsafe. So just like games, it's very important for HMIs to have good fidelity in real time. Another one of the important ones also is the ecosystem with scalability. Just like in games, how you're deploying to all kinds of maybe mobile devices or different consoles, different spec computers. Cars have all kinds of different hardware, mobile hardware, and it's important for engine to be able to scale features so that you can maintain that high performance. And so, yeah, that's it.
Right. So next I want to talk to you about experience. Experience is the new horsepower. Digital screens is now one of the new defining features of a car. Technology and digital experience will have the biggest leap in both design and abilities in the next few years. The in-vehicle digital space is becoming more important than ever. It's one of the fastest growing spaces in automotive, especially with vehicles becoming more software driven. The content will only continue to evolve as hardware and software rapidly gets more advanced, allowing us to create better overall digital experiences for our customers. So we get asked this too, why Unreal Engine for Ford, right? So the reason why we're using a real-time experience is because Unreal provides the customer with interactive content and experiences that just can't be done with pre-rendered assets. Tom?
Oh yeah, and a major differentiator with Unreal compared to other automotive HMI tools is that there's a large, robust community and tons of resources available online for development, which, when you compare it to HMI-specific tools, it's, that just isn't there for those. So that's major for us.
Yes. So I want to talk about design tools being more impactful and the immersive reviews that we get with using a tool like Unreal. Unreal supports our entire pipeline, allowing us to ingest data, visualize concept, and prototype and lead into production. And that's key because we want to get our designs out there in real time and functioning, from the beginning, right? So we work together with software engineers, that's also a big key, right? And to optimize and test our design much earlier. So there is less back and forth with solving issues that arise on performance or even experiences. We don't want to just throw something over the wall and hope for the best, right? So Unreal Engine is not only used with digital product design, but it's also used for other design departments outside of the digital space, right? When we have exterior design, interior design, and even marketing using Unreal Engine. We're just the first to bring it into the vehicle. Unreal made it remarkably easy to take a design comment from our reviews and action on it with everyone right there because it's live, it's real time. There's no need to go back to your desk and turn on your machine and flip through and load Maya or any other application. You can just do it right there, right? So the next thing I want to talk to you is like how that leads to everything being ultimately dynamic, right? These are the core elements that we're looking for right there in those bulletin points for building an insanely great real-time experience. We want there to be a design-driven experience, right? We want user-led immersive experiences. We want people to interact and drive the complex product stories, connect physical to rich visual outputs. We want unlimited flexibilities on our asset creation and exploration, right? We want to be nimble enough to do late changes. And all this leads to an agile workflow. And for that to work, we need one source of truth. We need one tool. We need to use Unreal for both pre-production and production work. Unreal empowers us to develop numerous amounts of content quicker than we have in the past with a small but mighty team. It creates the opportunity for most of our work to be interactive from the get-go.
Yeah, and so one of the things you're going to see here in the next couple minutes is the Unreal Engine kind of HMI workflow that is very, very different from traditional HMI workflow. In the past, a design team would create assets and then give them to an engineering team, which would then use a tool to get it into the car. And that is a very kind of linear progression where the feedback loop is very long. Sometimes it can take months for designers to see their designs in the product. With Unreal Engine, because the editor can deploy directly to hardware, because designers can add their assets using version control, all of these things contribute to the designers being able to work directly on the project that goes into the vehicle. And so instead of giving assets to engineers, you're staying within the engine, you're iterating, and that prototype becomes the final product over time. And so you're gonna kind of see this workflow kind of shown off here.
All right, next I want to hand it off to Sky Waters here to walk us through the vehicle configurator.
Yeah, so this is a vehicle configurator that we actually created to serve as a tool for us to be able to review the content that we are creating in the vehicle. As you can see, it's run on Unreal Engine, and we've created different variants. There's different trim levels on the exterior. We can click through the different wheels. And traditionally, this would be done as a review with like a presentation or a 2D asset or image. And now we can actually do this with a real live 3D environment that is a lot more immersive and more accurate of what we would actually see in real life. Additionally, we can import engineering data and not have to do any optimization through Datasmith, and this makes it a really fast workflow that Unreal is able to actually handle all this data sets that we're using that's very high poly. We've also been able to import different, there's different questions that we have to think about when we're making these creative decisions in the vehicle, like how does the journey of the user impact what we are creating, and also what kind of stories can we tell by seeing this in the vehicle. So as you can see, we're in the interior. We've got these door-in animations that welcome the user, and then it ultimately goes up into the HMI experience. We can see we've got different cluster themes and center stack, and what's really cool about this is we're able to actually see these designs side by side, and there's a lot of features in the vehicle. And being able to see it in a digital space like this is very important when we're reviewing this content.
Yeah, just to add to that, Sky, showing all the stuff in context, this is our digital space here. However, seeing that interior exterior all together just helps visualize this and see all in context and helps sell our designs much more effectively. I'm going to click through here a little bit and just kind of show you guys some of the features here. So we've got our different trim levels. Got our base, got our GT Performance, and the Dark Horse. We've got our different rim packages. We've got base, another base, GT. Here, let me get on the rims for you. Performance package, and the Dark Horse. We've got our different welcome animations. So lighting approach detects the user's key fob. You got different lighting approaches. Change your paints. Got door interactions. We've got multiple environments. You guys may have noticed this one from Epic's release for their configurator. Jumping back in the interior. Close the doors on that. So cluster-wise, we've got our different clusters. We've got normal, calm, sport, track. Got 2 variants of Fox body, one for daytime, one for night. Going to center stack, just visualizing some of this content. Got our climate, home screens, our aux gauge, 3 5-gauge layouts, my Mustang home screen that you'll see soon. My color, part of my Mustang. Another snippet from my Mustang, and phone screens. And again, we've got just our ambient lighting. And a lot of this stuff, like I said, is in our digital space, but it helps just tell the story. And it's much more impactful. And taking our Xbox controller, you guys can give it to leadership, and they can kind of scroll around here and play around and lock in their own compositions if they want to, playing with depth of field, locking it in. You got your screenshot capability, so reviewing this, boom, you do a screenshot, save to the path, send that out. Sky talked about the day and night variants. We've got a weather system in here. And this is version 1 of our configurator, so this is definitely going to be evolved much, much more, but I thought it was a good start. Is there anything else you guys want to add to this?
Yeah, I mean, like, we're adding more and more features as we progress our HMI. So the weather system is something that we can look into when you're seeing the weather in your vehicle, and if you're inside your vehicle checking out, turning on and making sure that the weather icons and the graphics, you can actually see that inside your vehicle with the rain effects while you're reviewing the vehicle. There are certain, design challenges that you may not realize until you sit inside of the vehicle. And this was designed during COVID, so we couldn't go and sit in a buck, us designers with, design managers. So having this configurator allowed us to react nimbly and quickly when we could see it directly in front of us through this application, rather than waiting until the buck gets created and then coming back much later and having to redo the design. Yeah, all right, well, next I want to go into the POC that we worked with Epic Games to create to get us into where we are today. This is where it all started, all right? So we ran a proof of concept 2 years ago to figure out how a game engine works better for real-time production as well as early visualization. So we decided to do some benchmarking with several engines in the market. We worked with them to create an application that run on similar hardware as well as our current hardware at the time, just quite limiting. So we can have that range, right? So we can understand where these real-time engines can fit in, will they work, and how far can we push it? And this was the result. We worked with a team to create an application that run and gain the most traction throughout the design and software engineering organization. And from there, we worked, the work we did on the POC with the Unreal Engine allowed us to concept and get it running on hardware very quickly. It provided designers friendly tools with blueprinting that enabled their designer to design experiences without the need for developers. Because this was really quick. We had to do this POC fast so we can make a decision on where we want to go next, right? So then we send them the assets and have them integrate it into the code. Essentially it became a very scalable tool. Next, I want to hand it off to Justin here.
So, here, scroll down a little bit. This is pretty much an early prototype of us deep diving into the My Mustang. We kind of pivoted off the MVP originally, and this allowed us to jump into that. So a lot of the features you see in here, this is like early wireframing UX in jumping into the My Mustang section. So I'm going to load that up and we can talk about that. All right. So right here, what you're seeing, this is the first in-vehicle experience for Ford Mustang created in Unreal Engine. This is a tool that allowed us to pivot from the minimal viable product and enhance the experience relatively quick in terms of software development time. It allowed us to become more agile in the process and begin to bridge the gap between our developers and designers, allowing for easier, quicker design ideations. Connected our designers at a working level of software development, improved our communication and blurred the lines between our skill sets. We utilized version control to collaborate on large projects and large teams, locking files, reducing merge conflicts, maintaining, tracking, and test changes. Utilize UMG for aux gauges and the user interface in addition to just the vehicle visualizations. And this allowed our team to work directly on embedded hardware, designing and seeing directly what impact designs decisions had on performance, essentially getting real-time feedback. And ultimately, it educated us on the limits that we had in our hardware, where we could go, where we could take it, and helped us inform future decisions. So I'm gonna jump in and just demo this Mustang for you so you guys can see this. Get that out of the way. So what you're looking at here is just the isolated My Mustang app. It's a fully Unreal contained app. So starting at the top, we got track apps, which is pretty self-explanatory. We've got acceleration timer. These are your different drive types. You got 0 to 30, 0 to 60, 0 to 100, eighth mile, quarter mile. You've got your acceleration start types. So this is a visual cue in your cluster. So all this stuff you see in My Mustang is pretty much just a setup for everything. You're gonna have visual cues and timing and direction in your cluster. And these are different track lights, drag race lights, track race lights. We've got our brake performance. This is how quickly you're braking, pretty straightforward. We've got our lap timer. This is based on the test tracks you would be going to. So you got multiple tracks here that you can set up and see results. And obviously this is all test data in here. This is still in production. We've got our launch settings, setting your RPMs for a visual cue in your cluster on your tack. So you redline it. That's when it's gonna tell you, hit it and launch. We've got a rev match. That is very similar. Where is that? Let's scroll down real quick. Rev match is pretty much just getting your RPMs to accelerate and decelerate based on shifting. We've got our aux gauges here. We've got a 3-gauge layout and a 5-gauge layout. And within these gauges, you can customize any one you want. Come in here and configure whatever you want on your display. And again, do the same thing on the 3-gauge. We've got custom mode. So jumping into this, you got your base drive modes. These are gonna be global indicators here. So if I'm on sport, obviously this is test data and it doesn't reflect that in the image you're seeing. This would go to sport, go to drag or track. These would all be track, and then you can adjust these independently. Jumping into these, we've got adaptive dampers. This is just tweaking the tightness of your suspension. So normal, sport, track, and drag. We've got our steering. Again, tightness of your steering, normal, sport, comfort. We've got our traction control. Traction control's on, it's more stable. You turn it off and you can kind of do drifting, burnouts, and whatnot. Enables more freedom in your Mustang. We've got our active exhaust. We've got normal, sport, track, and this is more of like the level of sound of your exhaust. Auto start and stop, pretty straightforward. Your stoplight shuts off your engine, idles, turns back on, so you can set it up for your profiles within here. We have our clusters. You got normal, sport, calm, track, and fox body. And you can save all these to any profile, so you're tricking that out. You can go back to your first profile, do another one, and you got up to 6 of them that you can do. Within any time in this, it's all real time, so you can turn around the car, you can play around with it, and move it around, and it's available for interaction on all these screens. Jumping into my color, this is more of like allowing the customer to have a little bit more input on just customization. So we've got our primary, we've got our secondary, and within the ambient lighting, you've got your different color swatches, obviously. You go into my color, so we switch this to a red and a blue, and if you go into aux gauges, you'll see more of a visual indicator of what's happening here. So you can go back and change your colors based on what you prefer. Going in cluster themes, You might have noticed that cluster themes was in custom mode, and there's one out here. So this is more of a quick control. So if you're in like sport and you like the track layout, you can come in here and say, hey, I want track with sport layouts, and it's more of a quick control similar to exhaust mode. So these are high level, so you don't have to go deep into the experience. And I think I covered everything. You got anything else to add to that?
No, you shouldn't. I mean, everything's live, and one of the key things that we learned while we were doing this is, we had this all locked down because we didn't want the customer to be driving their car and like messing up the vehicle. But one key thing that we found is that if this vehicle's live, the customer want it live. They want to like tweak and make sure it moves whenever they want it to move. So that was brought up to us by one of our design managers, and we just made it happen. We just unlocked the feature, and we made it just live, and in any of these modes here, you can actually go in there and rotate the vehicle wherever you want. So just a nice little, feature that we can implement immediately, because it's in real time. It's as easy as just turning on.
One thing to add too, this functionality existed already in the existing Mustang. We just ported it over to the center stack for more real estate, especially the aux gauges, a lot going on in the cluster. So this just allowed more immersive interactive experience using Unreal and center stack.
All right, next I want to introduce you to our lead real-time graphics specialist, Tom Bowen, to go over the optimization and profiling for the embedded hardware.
Yeah, so my role in this project was primarily material creation and performance and optimization analysis. We're finding, like, as technical artists now, we're really straddling the line between design and development, and having the understanding of the complete development process and what techniques work well in embedded hardware is like critical to like a successful project like this. The lines between design and development are just becoming really blurred for HMI now because we lean into this sort of more game development centric process. One of the big aspects working on embedded hardware is that, this isn't the only thing running. We're working with like a sort of full stack of services and systems on the back end. So, with regards to performance, it's like critical that we're cognizant of the impact of our implementation on the target hardware. So, not only we're pushing for the best possible frame rate, but we have to stick within some underlying constraints with regards to startup time and memory allocation. So we have to be aware of that. So in today's age of like ultra responsive HMI, like we're all used to like Apple devices running like 60 frames a second. It's critical that we implement any possible performance improvement that we can when we're working on it. But we also have we have to answer to design team and keep that original design vision while we're doing that. One of the things that was vital during production is that as technical artists, we had to get used to compiling and flashing to the embedded hardware so that we could sort of get that iterative testing cycle going and be aware of what our sort of design changes were doing on the target. So the result of that is that we all had the target hardware next to us by our workstations. So we really had to get our hands dirty with assembling the modules, flashing and testing the content on hardware, QNX console commands, triggering vehicle signals with CAN devices so we could enable and disable certain features on the hardware so that we could see what they were doing. And that was for some people that's a huge step for the typical technical artist because you're really becoming like a software engineer at that point. So but it was we truly believe that was critical to the success of this program because we could do that iterative testing as designers, as artists, and see how it's responding on the target hardware. And you really enjoyed that process.
I loved it. Yeah, Tom's absolutely right, though. It's so critical how we're working with Unreal and working on our embedded hardware that we need to be able to flash this and test this on the hardware to really get a readout where we're going performance-wise.
Yeah. So for the implementation on the target hardware, it was really important for us to be able to analyze the design team's vision and for the gauges and the vehicle visuals and be able to meet the performance and startup time requirements on the target. So digging around a little bit, so with regards to the gauges, that involved utilization of alpha masks packed in 4-channel textures with some procedural elements in the materials. And that sort of base material will be instanced for all the different gauge types, and we made use of like static switches to control the different behaviors. We did look sort of earlier on into completely procedurally generating the gauges through the material, but working on embedded hardware and especially in some of the 5-gauge views, that would mean that material is taking up quite a large screen percentage. So we had to be very cognizant of the instruction count, and so we opted for this other method to use the channels for the masks to keep them, and it was successful. We were able to keep the asset size down and get some really good performance there. So then, with regards to the vehicle model, we analyzed the target, looked at the designs, we built custom materials around the design. So we had the control we needed and the fidelity the design team was looking for. So that was like a combination of masking, vertex painting, some custom Fresnel calculations and manipulation of the cube maps. And there's some baked elements to it, but our goal was to match the design intent and keep that performance going. So this method we could meet our startup time and requirements and performance requirements. So, and Justin did a great job with model optimization. He did a lot of work with manipulating the normals and a clever use of instancing with vehicle geometry to keep that startup time down. We also used, of course, Unreal's sort of onboard performance analysis tools with regards to checking overdraw, texture memory footprint and optimization, and also saving out utrace files on the target hardware for analysis with Unreal Insights, and that was really useful for us. And we also took advantage of things like render scaling and management of the post-processing workflow, so that we could handle what effects or features that we weren't using, so that we could have a nice streamlined render pipeline. So at the end of the day, working with embedded hardware, it's important to remember, like, everything has a cost. And it does also with mobile, but I know it's far stricter when we're working with embedded. Everything has a cost, and so there are times where we'd had to take a step back and say, like, is this the best way to implement this? And we had to not be afraid to question ourselves and start again and maybe use a different technique. So it's important not to be afraid to try different methods if something isn't working. When you're working with embedded hardware, or when you're working with anything really. But you'd scroll down a little bit there. So yeah, and when working with such a large multidisciplinary, multi-team group that we're working with, we've got software engineers, we've got hardware engineers, that the design technicalities guy doesn't want to be the guy that tanked performance because he didn't do his due diligence when he was creating materials for the wheels on the Mustang. So it's really important for us to do that iterative testing, do our due diligence to make sure that we're not affecting the whole complete package. And yeah, that's what I get.
Yeah, I think one thing to add to kind of an interesting thing we came up with working and testing this stuff on embedded hardware is we found out MSAA wasn't working really well and didn't look as good, and we found out temporal anti-aliasing worked really well, and kind of interesting. We didn't think we could do that. It's not mobile supported, and now we're using it in the Mustang, and it looks better than MSAA on our hardware.
Yeah, and so it's interesting what you're hearing. You're hearing the design team at Ford deciding on the design decisions to achieve the production performance that they need to achieve. And that's actually quite new. In the past, optimization decisions were made by engineering, and I'm an engineer by trade, and I can say that I don't have the best art eye. So it's good for optimization decisions that affect design to be made by the designers themselves, because they have the design vision, and so for them to be able to do that was very effective.
Is there anything else to add? I'm going to play out a cinematic that we created for the marketing reveal. All of it was created in UE5 just to support the marketing because a lot of this content is still in pre-production. I'll play that.
I think you muted it
I
earlier.
did mute it. My bad. All right.